Hi, this is Yi from Inspur China. In this topic, I will talk about OS DPDK performance issues and how we fix them and make OS DPDK a first-class citizen in Openstack. Here is my agenda. I will elaborate OS DPDK performance issues, our solutions to them, implementation standards, and the implementation details of these solutions. Then I will show you performance data in my deployed OpenStack environment to-do list in the future. At last, I will demonstrate performance test in my real OpenStack environment if the lifetime is enough. Current OS DPDK community version does have many performance issues. I have talked them in OS conference in last year. VM-to-VM performance is bad, especially TCP performance. The key reason is OS DPDK cannot support VXLAN TSO, GRO, and GSO. Here, VM-to-VM communication means two VMs are in different compute nodes, but in the same subnet. VM layer 3 routing performance is also bad because there is a temp interface involved in this data path. Temp interface performance is very bad in OS DPDK. Here, VM to VM layer 3 routing means two VMs are in different subnets. They communicate with each other by QRouter. Temp interface is in QRouter network namespace. VM to VM floating IP performance is bad too because there are temp interfaces, IP tables, and connection track involved. VM to VM floating IP communication means two VMs use assigned floating IPs to communicate. In addition, UDP packet loss rate is very high in current OS DPDK community version because of poor temp interfaces performance, poor IP tables performance, and poor call track performance. Here you can see OS DPDK community version has very low DCP performance. OS kernel and our improvement patches are much better than it. As aforementioned, the key reason is the current OS DPDK cannot support VXLAN TSO, GRO, GSO. VXLAN TSO means hardware NIC can do TCP segmentation offload against a big VXLAN packet in which there is a big TCP packet. GRO is generic receive offload. GSO is generic segmentation offload. They are done by software itself. For big UTP packet, OS DPDK community version is better than OS kernel, but it is still worse than our improvement patches. For VM to VM layer 3 routing performance, OS DPDK community version is much worse than OS kernel and our improvement patches because temp interface in QRouter makes the result worse. VM to VM layer 3 PPS performance is also bad. It's the same reason. Our improvement patches can fix it very well. Here, small UDP packet performance is also bad. For big UDP packet, the performance is much worse, but our improvement patches can fix it. VM to VM floating IP performance is banned because there are more interfaces with peer interfaces, IP tables, and call track involved. You can see OVS kernel and our patches have super good performance for floating IP TCP. Here, floating IP PPS performance is also banned. For UDP packet, small UDP packet, the performance is banned too. For bigger UDP packet, OS DPDK community version cannot work at all because IP tables will fail to reassemble UDP fragments, but our improvement patches can fix it very well. Here you can see current OS DPDK community version has very high packet loss rate for 16 bytes UDP packets. For floating IP L3 routing, packet loss rate is still high. Floating IP layer 3 routing means two VMs are in different compute nodes and different subnets. They communicate with each other by floating IP and QRouter. So far, you have no current OS DPDK community version does have so many performance issues that it is not usable in Openstack plus neutral environment in case of DVR mode. But fortunately, we have had solutions to them. For band VM to VM performance, we developed many patches for DPDK and OS DPDK, including VXLAN TSO, GL, GSO. Of course, we also need hardware NICs to offload VXLAN TSO. For example, Intel 700 series, 800 series, Mellanox Connect X series, etc. For band layer 3 routing performance, band floating IP performance, higher packet loss rate, we developed patches for Neutron, OSKern, Nova. They use OpenFlow to implement layer 3 routing, floating IP, SNAT, floating IP QoS, so no type interfaces involved in the data path. Our DPDK patches and OVS patches have been uploaded into my personal GitHub repo. You can apply them against corresponding DPDK and OS versions and improve your virtual network performance significantly. We also proposed a spec for Neutron. It has been approved by Neutron core members. The implementation code is also there. You can apply them to your OpenStack and enjoy huge performance boost. For DPDK part, we developed many patches for GL and GSO. So far, we can support IPv4 in IPv4 VXLAN, IPv6 in IPv4 VXLAN, IPv4 in IPv6 VXLAN, and IPv6 in IPv6 VXLAN for both TCP and UDP. Some patches have been merged into DPDK 20.11. For OS DPDK part, we developed 47 patches. They enabled VXLAN TSO and the GL and GSO support. enabled UFO for vHost user, enabled tpacket v2 support to temp interfaces. For Openstack part, we enhanced OVS CAN to support the serial packet in too. This is used to support user data in controller action. OVS CAN is a Python-based SDN controller. Neutron OVS agent used it. For Neutron, we implemented layer 3 routing, floating IP, SNAT, floating IP QoS by OpenFlow pipeline. We also fixed the OS DPDK restart issue by changing Neutron to set NetNS option for temp interfaces. For Nova, we enabled it to support legacy temp interfaces for VM. That means OS DPDK can launch VMs by using temp interfaces instead of vHost user interfaces. Maybe you're wondering why we want to do so, because this can enable tenants to launch more VMs and use more memory than physical memory. For vHost user, it is impossible not to use huge page. That means the number of VMs you can launch depends on total physical memory and the number of huge pages. To be important, once OS DPDK can support VMs with the legacy temp interface, VM can be live migrated from any one compute node to another, vice versa, no matter it is OS kernel node or OS DPDK node. Here is the OpenFlow pipeline we ended. We added many OpenFlow tables to handle layer 3 routing, floating IP SNAT, floating IP QoS, layer 3 SEO, policy-based routing, etc. Especially for floating IP, we don't use call track to handle it. This can improve floating IP performance much more. We used controller action with custom user data to trigger OS CAN to send ARP request for destination floating IP, and ended corresponding flows to learn MAC addresses from ARP replies. This is special stuff for floating IP OpenFlow pipeline. You can read the source code we posted into review.opendev.org for more details. Here we compared all the performance indices between OS DPDK community version, OS kernel, and OS DPDK plus our improvement patches. You can see our patches have super good performance data in every performance test cases. Our patches improve the TCP performance, UDP performance, PPS performance, and packet loss rate dramatically. For the case VM uses temp interface, we also compared all the performance indices between OS kernel and OS DPDK with our improvement patches applied. You can see the performance data is not that bad. They are beyond our expectation. That is to say, its performance is acceptable compared to OS kernel. In the future, we still have some jobs to finish. We need to verify IPv6 in OS DPDK in OpenStack environment. We need to implement IPv6 support by OpenFlow. We also need to support centralized network in Neutron by implementing floating IP port forward and centralized floating IP. We also need to remove duplicated code in OS agent and layer 3 agent for network namespaces because we have implemented them in OpenFlow. We needn't them anymore. We still have many patches to push into upstream repo, although some patches have been merged. For those leaks which don't have VXLAN TSO feature, the performance is not good yet. We need to try our best to improve. At last, you can download my pre-recorded video to see real performance data from my deployed Openstack and OS DPDK with our improvement patches applied. Here is the demo.
All right. Thank you, Yi, for your work and your presentation. Are you able to join the session so you can respond to questions in video and voice? We have a couple of questions from the audience, so it would be great to have you here. Oh, I see that you're joining. Great. Thanks again for your presentation.
Thank you.
So let me read the questions from the audience. So William too says that that he likes the work and that we've hit similar issues at VMware. And his thought is that, you know, if it's so bad, should we use the kernel instead? And why should we use OVS DPDK? Or, you know, if we do continue to work on OVS DPDK for this purpose, will it ever get to the point where it's better than the kernel? So do you have any thoughts along those lines?
Can you hear me?
Yes, we can hear you just fine.
Sorry, I don't get your point. You mean why we use OVS DPDK instead of OS kernel?
Right. So William is asking whether the kernel would be better for this particular purpose. I think that does the question make sense? If it doesn't make sense, then we could try the other question from Ilya.
Okay. We can go to next.
Okay. So Ilya says, it seems that the main problem for your setup is that you're sending traffic back and forth between kernel and user space. It's likely that OVN can implement all of this completely in user space with OpenFlow, avoiding the QWriter namespaces and IP tables. Did you try that?
Yes, but you know, we have deployed very many all the OpenStack systems. That they don't use OVN. They all use all OpenStack neutron. We need to support them, right? We need.
Okay. I mean, OVN is a layer, is one implementation of OpenStack Neutron, if I understand the layering right. You're saying that they're using some other implementation of OpenStack networking.
Yeah.
Okay. So do you have any additional thoughts to offer, or do you want to talk about the future of this work at all?
Yeah. Actually, we did have some features to implement in the future, you know. And we mentioned in this talk for IPv6, actually we didn't verify them very well. So in the future, we need to verify IPv6 support in our OpenStack environment and improve the performance.
Great. Thank you for those thoughts. And I thank you again for your work and for the talk. And I know that we've heard from you before, and we'll look forward to hearing from you again in future OVS conferences.